Dear student, and now let us discuss one very important the result using integration of the vector function, right? So what is that? That theorem is called as Stokes theorem. Stokes theorem. So before going to discuss the problems under Stokes theorem, let us understand the statements of the Stokes theorem. Now, to understand this, let us consider a region R of the xy plane. Let R be the, have a look on this. Let R be the region, some region. Let R be the region in a xy plane because it is a two-dimensional aspect in a xy plane bounded by a simple closed curve C. Simple closed curve C. Curve C. And if I am considering two functions here, if m is a function and another one is n is a function, but both m and n are the functions of x and y because we are considering a xy plane. If x comma y, m of x comma y and n of x comma y are two continuously continuous functions having first order partial derivatives. First order partial derivatives. Very simple statement. Partial derivatives. Okay, once again understand. Let R be the region of the xy plane bounded by a simple closed curve C. And if m of x comma y and n of x comma y are two continuous functions having first order partial derivatives in region R. Then what's the result here? Then the result says that the line integral under curve C m into dx, have a look on this, plus n into dy, have a look on this, line integral over a curve C m dx plus n dy is equal to surface integral this is under region R, I am right, R dou n by dou x. So here n is the coefficient of dy, m is the coefficient of dx. Therefore we need to find out the partial derivative. Look at that, dou n divided by dou x minus dou m divided by dou y. ಸ್ವಲ್ಪ ಉಲ್ಟಾ ರಿವರ್ಸ್ ಮಾಡ್ಕೋಬೇಕು, dou y into dx into dy. This is a statement. So once again understand this. The Stokes theorem says that line integral of m dx plus n dy over a closed curve C is given by a double integral over the region R dou n by dou x minus dou m divided by dou y into dx into dy. This is the statement of a closed interval. That means a Stokes theorem where R is a region in the xy plane bounded in the closed curve C where m and n are given in terms of x and y. This is a statement. Okay, now to do the problems here, what are the steps here? First, identify m and n in the given problem. First, identify m and n in the given problem. This is a procedure. So then find out dou m divided by dou y. Have a look on this. dou m divided by dou y, and here what? Dou n divided by dou x. This is the first step. So first identify m and n in the given problem. Then find out dou m divided by dou y and dou n divided by dou x. And further what to do here? So after getting this, consider the given two curves. They are given the curves here. That means C. So from the two curves, find out the point of intersection. Point of intersections. Here you are going to find out the 2 points here. 2 points of intersection. After getting the 2 points of intersection, let us apply the Green's theorem. So that means not this is a Stokes theorem. Sorry, this one is a Stokes, not Stokes theorem. This is a Green's theorem. I am extremely sorry. This is a Green's theorem. Okay, this is a Green's theorem. Sorry. Okay, let R be the region in a xy plane bounded by a simple closed curve C, and if m of x comma y and n of x comma y are two continuous functions having first order partial derivatives in region R, then the line integral of m dx plus n dy over a closed curve C is given by double integral over the region R dou n by dou x minus dou m by dou y into dx by dy. This is the statement of the Green's theorem. So to do the problems in the Green's theorem, first identify the m and n, then find out dou m by dou y and dou n by dou x. Now consider the two given curves. By using the two given curve, find out the point of intersection here, then write down the Green's theorem. So then after getting that, find out the LHS. The next point is find out the LHS. What is LHS here? The line integral over C m dx plus n dy. After finding this is m dx plus n dy, then find out RHS. So what is RHS? This is RHS, the double integral over region R dou n divided by dou x minus dou m divided by dou y. So instead of dx into dy, you can take dy into dx. Because why? Because the first here we have the two integrals. The first we are going to integrate with respect to y. Thereafter we are going to integrate with respect to x. So that instead of dx into dy, you can make like this dy into dx. So then compare LHS and RHS. If they are equal, then the Green's theorem is verified. This is what. Okay. Let us understand a very important problems related to this. Okay. I am going to write a very beautiful problem. Understand the question. Once if you understand the question, it is very easy to handle the problem. I will go in a simple way. These are the very, very important questions from the point of examination view. Okay, the question is what the questions are. Verify Green's theorem in a plane. Why it is plane? Plane because it is a two-dimensional. Verify Green's theorem. Verify Green's theorem in a plane. The plane they are given like this. In a plane. So line integral over C 3x square minus 8y square. Understand the question? Into dx. Plus 4y minus 6xy into dy, where C is the boundary of the region, where C is the capital C is the boundary. It is a curve. Is the boundary of the region. Boundary of the region. They are given the boundary condition. Boundary of the region enclosed by so enclosed by y is equal to root x and y square is equal to x, and y is equal to x square. Okay, now to verify the Green's theorem, by using the given data, what to do here? First, let us identify m and n here. Solution. Have a look on this. So let m is equal to, what is m? So compare this like this. This is m dx plus n dy. This is m dx plus n dy. Where m is equal to, what is m is equal to? 3x square minus 8y square. According to the Green's theorem, we have the partial derivative of m as dou m divided by dou y. So when we are differentiating with respect to y partial derivative, the term x become a constant. So therefore derivative of 3x square is 0 because there is a absent of y term here. This entire thing become constant, derivative is 0. Minus 8 into y square is what? 2y. Therefore dou m divided by dou y is equal to minus 16y. This is what. Now let us consider n. N is the second function, 4y minus 6xy. Now let us find out dou n divided by dou x. So then y term become constant here. 4y is entire thing is a constant minus 6xy. This can be written as, this is nothing but 6y into x, right? 6y into x. So 6y is a constant into x is answer is 6y only. Therefore dou n divided by dou x is equal to minus 6y. So this is the first step. So first we are going to identify the first function m and the second function n. So the partial derivative of m with respect to y and the partial derivative of n with respect to x, that is nothing but dou m by dou x and dou m by dou y and dou n by dou x. After getting this, consider the boundary conditions here. What are the boundary conditions here? Let I am considering here y is equal to root x. Another condition is what? Y is equal to x square. Have a look on this. Have a look on this. Y is equal to root x is nothing but y square is equal to x. Y square, I can write simply y square is equal to x by squaring it, and this can be rearranged as x square is equal to y. So this is in the form of y square is equal to 4ax and this is in the form of x square is equal to 4ay. These two things are the parabolas. So when the thing which is in the form of y square is equal to x, which is a parabola on x axis, x square is equal to 4ay, which is a parabola on y axis. Keep in mind. So now we have to find out the point of intersection. Here y is equal to root x and y is equal to x square. Just have to take either substitute the value of y is equal to root x here or substitute the value of y is equal to x square here. You will get the same thing. So I am going to substitute here the value of y is equal to root x, that is equal to x square. In order to remove the square root, have to make the square on both sides. What happens here? X is equal to x power 4. Then x power 4 minus x is equal to 0. Then x is common here. Don't divide by x. Right? So that becomes x cube minus 1 is equal to 0. Then x is equal to 0. Or you can take x cube minus 1 is equal to 0. Then x cube is equal to 1. X is equal to 1. We have two values of x. Now I am going to write when x is equal to 0. Have a look on this. When x is equal to 0, y is also equal to 0. Again, when x is equal to 1, when x is equal to 1, y is also is equal to 1. Therefore, point of intersections. What are the point of intersection? The first point is 0, 1, 0, and the next one is what? 1, 1. What it means? The value of x varies from 0 to 1 and the value of y is also varies from 0 to 1. This is the concept. Next, after finding the point of intersection, what we wish to find out here? So now use the Green's theorem now. Use the Green's theorem. What is the statement of the Green's theorem now? You can find out the Green's theorem statement now. Okay, now, so using Green's theorem, understand this. Using Green's theorem. What Green's theorem says that here? What Green's theorem says that? Now it is a line integral of m dx plus n dy over a curve, closed curve C is equal to a double integral over the region R dou m. So that is dou n divided by dou x, dou n divided by dou x minus dou m divided by dou y into I have written here dy into dx. Now let us find out one by one here. Okay. First let us find out LHS. What is LHS here, sir? So LHS is very important. LHS is a line integral over C m dx plus n dy. Okay, now in order to understand this, so after getting the point of intersection, keep in mind the point of intersection is 0, 0 and 1, 1. So now let us understand this. To get that, I have to make something here. Okay, so what is that? I have to write the two parabolas here. The first one is what here, like y is equal to root x, nothing but y square is equal to x, parabola on x axis, parabola on x axis. Okay, for your reference. And another one is what? Y is equal to x square, nothing but y is equal to x square. I can write y is equal to x square, which means what? X square is equal to y, parabola on y axis. Now let us write the figure here to understand in the better way. Okay, now what is that? So this is what this is the curve that is y square is equal to x. This is the curve y square is equal to x. Another one is x square is equal to y. This is the curve x square is equal to y. So here x square is equal to y is the upper curve, y square is equal to x is a lower curve. This is O, origin. The point of intersection already know that O, 0, 0. This is another is A, that is 1, 1, the point of intersection. This is a region where we are going to find this. Okay. Now here this region is bounded by from 0 to A and O to A and A to 0. And this can be taken as, look at me, integral over the curve is, first one is OA m dx plus n dy plus another curve is there, integral from A to 0 AO m dx plus n dy. Got my point? So let us take the first one as I1 plus this second one as I2. Now let us find out I1 plus I2. So this is a line integral of m dx plus n dy. So this is just a symbolic form. The first thing can be taken as I1 and the second thing can be taken as I2. Now let us find out I1 and I2 individually. So I1 and I2. So I will rub it now. Okay. Okay, now have a look on this. This is very simple, very simple. Now I1 is nothing but I1 is along OA. I am going to write something here. Along OA. Look at the figure written on the board along OA. So along OA, x varies from 0 to 1. I am right. X varies from 0 to 1. 0, 0, 1, 1. X varies from 0 to 1. And the y is equal to x square. And the y is equal to x square, that is a curve, that is a upper curve. Then if you differentiate this, what happens here? dy is equal to 2x into dx. dy is equal to 2x into dx. Now this I1 is equal to integral along OA 0 to 1 m dx plus n dy. There is that. So that is a 3x square minus 8y square into dx plus 4y minus 6xy into dy. Just simplify this. This is a line integral from 0 to 1. So here wherever you find y is equal to x square and dy is equal to 2x into dx. Now have a look on this. This becomes 3x square minus 8 into y is x square is x power 4 into dx. Okay, now again 4 into y, in place of y I can put x square minus 6x into, in place of y, x square, and in place of dy, what we have to write? 2x into dx. So after simplifying all this 0 to 1, this quantity become, after simplifying and taking dx common, here what happens here? 3x square minus 8x power 4 plus 4x square into 2x, that is 8x cube, minus 6 2s are 12, x into x square into x, that is equal to x power 4. After simplifying this, that you will get, after simplifying that, the quantity become what? 3x square plus 8x cube, 3x square plus 8x cube, 3x square plus 8x cube minus 20x power 4, minus 20x power 4 into dx. Now you have to integrate this. This become 3x cube divided by 3 plus 8x power 4 divided by 4 minus 20x power 5 divided by 5. So from 0 to 1. Since it is a lower limit is 0, just apply the upper limit. So then it becomes 3 by 3, 3 by 3 that is 1, 8 by 4 that is equal to 2 minus 20 by 4 that is equal to 4. The answer is what? Minus 1. This is what I1. Now let us find out I2. That I2 is nothing but this second integral. It is along AO. Okay. Now along AO. What to do here? Along AO, I am going to write something here. Okay. This is a procedure how we are going to do this. Understand this. So along AO, y varies from, so here 0 to 1, from back 1 to 0. So y varies from 1 to 0, and so in the previous problem we have taken as y is equal to x square, but here y is equal to root x. Y is equal to root x. The lower curve, that is equal to y square is equal to x. If you differentiate, what we will get? 2y into dy is equal to dx. Now I2 become what? I2 become second integral. So I2 is nothing but AO. AO is from 1 to 0. 1 to 0. M dx. What is M dx? 3x square minus 8y square into dx. Have a look on this. 4y minus 6xy into dy. Now just substitute the values here. This is from 1 to 0. 3x square, x is y square. Have a look on this. X is y square. So these are the values of y. Okay. Now you have to express completely in terms of y. So x is equal to y square. Then x square is equal to y power 4. 3y power 4 minus 8y square into dx. In place of dx we can write 2y into dy plus here 4y as it is minus 6 into x is nothing but what? Y square into y into dy. So now we can take 1 to 0, we can take dy as common here, dy, and multiply that 3y power 4 into 2y, that is 3 2s are 6y power 5 minus 8 2s are 16y cube plus 4y minus 6y cube, which on simplification, that what you will get, I2 become 6y power 5. So that is equal to 6y power 5 minus 6y power 5 minus 22y cube, 22y cube plus 4y square by 2 plus 4y square, that is not that 4y, that is 4y into dy, which on integrating this becomes 6y power 6 divided by 6 minus 22y power 4 divided by 4 plus 4y square by 2 from 1 to 0. Here no need of applying the upper limit because upper limit is 0. Upper limit minus. So the upper limit becomes 0 minus lower limit. What is the lower limit become? So by applying this become the quantity is 1 minus 11 by 2. Why? Because 22 by 4, 2 11s are 2 2s are plus 2 2s are. After simplification, that what you will get? I2 is equal to, what is an answer? I2 is 5 by 2 you will get. 5 by 2. Therefore, here I am going to write, therefore, the LHS become, what is LHS here? What is LHS? So, LHS is equal to, this become LHS is equal to I1 plus I2, right? I1 plus I2. So, I1, what is I1 here? We got that. I1 is minus 1 plus I2 is 5 by 2. Take LCM, 2 into minus 1 minus 2 plus 5, that you will get 3 by 2. This is what LHS. Let it be equation number 1. Or you can take this one as equation number 2. That's it. Okay, after getting LHS, now it is a way to find out the RHS. Once again, I will recall it. So, first identify M and N. Find out dou M by dou Y and dou N by dou X. Consider the two given curves. From the two given curves, write down the point of intersection and try to draw the graph. So here y is equal to root x and y is equal to x square. Both are parabolas symmetrical on x-axis and y-axis, and those point of intersection is 0, 0 and 1, 1. Now we have to find out, write down the Green's theorem. What Green's theorem says that, so integral over C m dx plus n dy is equal to double integral over region dou n by dou x minus dou m by dou y into dy into dx. So now let us find out LHS. LHS is this. But the curve is from 0 to A and A to 0. So we can split the curve into OA m dx plus n dy plus AO m dx plus n dy. This first one can be taken as I1 and the second one can be taken as I2. The first one I1 is along OA we are taken like that, and second one is along AO. Do this. After getting the LHS, now let us find out the RHS. How to find out the RHS, sir? Okay, now what is the RHS quantity? Understand? What is the RHS? Okay, now RHS. Okay, now what is RHS? RHS is double integral over the region R dou n divided by dou x minus dou m divided by dou y. I already said that instead of dx dy, make it as dy by dx. Now the region, the first integral is about x-axis, the second integral over y-axis. So x is varies from 0 to 1 and the y is varies from 0 to 1 itself. That is the y, the values they are given that y is equal to root x and y is equal to x square. So here we have to take the lower curve. Y is equal to x square is a lower curve, y is equal to root x is the upper curve. Dou n by dou x, already we got that. Dou n by dou x, what is dou n by dou x is minus 6y, dou m by dou y is minus 16y. Okay, after getting this, this become minus 6y minus of minus 16y into dy dx. Have a look on this. It's very simple, very simple. So this is x is equal to 0 to 1. So y is equal to x square to root x. So why we are taken y is equal to x square in the lower limit, y is equal to root x in the upper limit. Why? Because so y is equal to x square is equal to y, that is equal to downward curve. So y square is equal to x, it is an upward curve, it is an upper curve. Therefore x square to root x. So by simplifying minus 6y minus into minus plus 16y, that is equal to 22y into dy into dx. First let us integrate this with respect to y, that is equal to x is equal to 0 to 1, 22 y square divided by 2 from x square to root x into dx. This is over with respect to y. So now integrate what the value here, what the value. Now let us know here. Okay. So LHS already we got 3 by 2, right? Not 3 by 2, yes, sorry, 5 by 2. Sorry, 3 by 2 we got LHS. Now we'll move on to this. So therefore, that is equal to 0 to 1. This is the value of x. 22 to 11 is 11. Y square by 2. Apply the upper limit and lower limit. This become when your root x is there, root x whole square. Root and square get cancelled. what you will get? X minus and x square whole square, that is equal to x power 4 into dx. Take 11 outside, into this become x square by 2 minus x power 5 by 5. So from 0 to 1. 11 into this become 1 by 2 minus 1 by 5. Am I right? 11 into 1 by 2 minus, okay, not that. Okay, that is not this, not this, not this. Minus 6y minus into minus plus 16y, that is equal to 10y. I am sorry this. So 10y. So 2 5s are 5 is left. 5 is left. Here 11 into, take this become what? 10 is an LCM. This is 5. This is 5. 10 is an LCM. 5 minus 2, that is equal to 3. So 5 2s are, that is equal to 3 by 2. This is RHS. Let it be equation number 3. From 1 and 3, from 2 and 3, both LHS and RHS have the same value. Therefore, LHS is equal to RHS. It means Green's theorem is verified. Green's theorem is verified. This is how, okay? Understand this, how the problems are moving here, okay? From problem to problem, this becomes very simple to handle. Okay, now let us find out one more very important problem related to this Green's theorem. I hope you all understand well about this, okay?